Okay, so hello everybody, and welcome again in another week of our semesters, the new semesters. And this again we started with online stuff, but this times it will be a little bit different because occasionally we'll be coming up with WebEx lectures, so that will be more great. So yes, so this is the course, as you all already know, the probability and statistics with programming, and I have already uploaded the syllabus. And I saw the student list that some of the students already they took my lectures before, so you will be more familiar the way I follow my lectures style and approach. But definitely, it will be varying and it will be a little bit different because of online nature. So let's start with the course information that what we have for this course. And the main idea of this starting lecture is to motivate you for probability and statistics, so that you can be so enthusiastic to learn all these stuffs that we'll be covering. So see, what is this? This is the weather forecast, right? This is the Seoul weather. And exactly, you see, I just had this snapshot or screenshot from weather.com website, and it shows some weather predictions that what is the temperatures of today, tomorrow, or something like that, right? Tuesday, Wednesday, Thursday, Friday, Saturday, and in this way. And this is today's date, and this is the temperature is 6 degrees centigrade, and various kinds of things are listed here, right? So this stuff, these figures of numerical something, based on some record or whatever, this list itself is basically statistics. So it's all about some sort of data and collections of that, and analysis of that, manipulation of that, and most appropriately interpretations of those things. So these are basically statistics. So to learn and to present and to have meaningful information from statistics, we also need to know some concepts of probability. So that's the reason why our course name is Probability and Statistics Programming, because we need probability to understand statistics. Okay, so if you see, this is some little video I have for you. And if I play here, so see what is this. So this is basically, there are different ways of walking. When people walk, there are many ways. So in this YouTube video link, if you go, you will see there are 100 different walking style. So let's see it. For example, this is generic style. Normally people, this is feminine, this is snaking, this is angry mode. If someone is angry, perhaps he might walk like this. This is chimpanzee, and this is sassy, and dancing style walking. So something similar, right? So there are other ways, and there are other walking styles that you can watch that videos. So what is the idea here? So the idea is, okay, just wait. Okay, the idea is, you see here, this is a research paper. This is a research paper. So it's saying that, now how about the slow walking is more stable. People normally think like that. If we have slow, if we walk slowly, maybe we will be, having more stable walking, but that might not be true. But we can't say that. We really need to do some sort of research, and based on that research we can say, okay, someone if go fast, if walking faster, very, very slower, so what is the stable way of walking? So what is the stable way of walking? Stable way means that even though you give some sort of, let's say shifting or some drafting, but still he doesn't fall down easily, right? So this article, this research paper, they studied the effects of walking speed on the amount of different kinds of, kinematic variability and stability in human walking. And based on their research, they conclude that the slow walking is not necessarily more stable than fast walking. Okay, this is very interesting conclusion. Someone is walking slower doesn't mean that his walking style is, his walking is stable. So how they conclude that? They conclude based on different kind of, short-term analysis and long-term divergence analysis. They found out some mean standard deviation. They found out some sort of correlations. So you see, the correlation, standard deviation, divergence, what are those things? Those things basically is statistics. So it means, even this sort of, research and study, we need various kinds of statistical uses. So that is the idea. I mean, you really don't need to understand what are those terms, but at least now you know that these statistical terms are very much necessary whenever you study and do research in various, sorts of, perspectives. Without statistics, without probability, you can't do, I think almost research is impossible without statistics. So applications of statistics is really huge. It's not only just weather forecast that we explained. It might be, utilized a lot in insurance company, and based on the people's data, consumers data, their expenditure nature, their, buying habit. So if they analyze those all of this data, maybe then, the insurance companies, they can customize for home insurance, car insurance, health insurance, education insurance. So various kinds of insurance company, based on people's behavior and habit, when they do an analysis based on statistics, they can, utilized a lot in insurance company. Similarly, in various kinds of financial market, there are a lot of statistical uses. Also in medical drug testing, that the drug will be effective or not, then you need to test the very fast. For example, look at the coronavirus, the vaccination, right? So they do various kinds of testing, and those testing basically is statistical in nature. Also various kind of survey. For example, let's say talk about election survey. There is going to be, a election, the who is gonna, win. So that kind of, voting survey also conducted. And because politics is ultimately everything, so if you can manipulate in the politics, or if you can gain some insights into the political matters, so by using statistics, so it means you really have more knowledge in advance. And also, it goes, further. Perhaps about, this Go, AlphaGo, this Go game. And then you have the AlphaGo, this is computerized game. The chase, the Deep Blue. So right, so chase was the manual playing, the player was, playing the human. But then this whole algorithms has been, turned into some sort of, computerized process and algorithm. So that's underlying things all are statistics. So that's why statistics is so very much important. And you have heard of, today's name about, machine learning, deep learning. Those basics are all about, statistics. In fact, if you know the statistics and apply the statistics, those machine learning, deep learning are very, very easier for you. Because machine learning, deep learning, this is basically another name of statistical, applied statistical algorithms. So for examples, perhaps, you very often experiences this YouTube video, right? And there you saw that when you watch YouTube video, there you will see, various recommendations is coming. Those recommendations, how that recommendation is coming, that is also some statistical analysis based on that statistic, underlying statistics, that sometimes we say machine learning stuff. And then based on that kind of algorithms, we suggest that okay, you perhaps will be liking this video. Think about like this, for example, so there is one name called collaborative filtering, that how the for example, this user and this user, right? For example, this two person, you know based on their a previous reading history, so they suppose they read similar kind of contents, okay, they use similar kind of books or contents, whatever. Now let's say this guy, let's say this guy now newly read this book, so it means that this book will be recommended to this guy, right? Because based on their previous study they use the similar thing. So 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 it is very conclusive that when this guy will read these contents, so it means my recommendation systems, my algorithm will suggest this content to this guy, right? This is that much easy. So that is called collaborative filtering. So that's why if your friends somewhere over there, they watch some video, perhaps after 2 days or after 3 days or maybe after a few days, you might see the same video in your list. It is because there are some algorithmically they know that you are somehow related, maybe from your Facebook login and history and pattern, or maybe your searching pattern, and then they know that you two friends somehow are related, so the one's activity will be recommended to others. Similarly, see the content based filtering, that this user basically read this content, and perhaps they found a similar article, so these similar articles will be recommended to this guy. So that means based on my reading history, now the new contents might be recommended. So this is also, again, the background is all about statistics. Okay, so the list basically goes on and on. Okay, environmental study, natural science study, in agriculture, crops productions, or that based on weather condition, that how much agricultural productions will have, various kinds of online reviews and analysis, shopping recommendations, travel business, biology and genetic engineering, marketing companies, human rights and social justice, even the government for their budgetary systems and various other kind of things, they use statistics. So in a nutshell, the applications of statistics are basically a huge, right? And the today's things, today's phenomena, today's our world basically algorithmically controlled, and this is possible because of data driven things. All there are data, so if you have the data, so then you can come up with this data driven some insights. So here you will see there is a small clip for you, and in this clip you will be seeing that some very famous guys, they who are working in different kinds of institutions, educations, or different kind of scientific and research institutions. They are quite famous in statistics and machine learning area. So even how they motivate you to start to study statistics. So let's see a very little clip, not entirely, just a few.
So in high school, I had never even heard of statistics. And I knew I liked math, and I knew I liked science.
In high school, I went to a conservatory for music. I was a viola performance major.
When I started college, I was taking a bunch of math and economics classes. And then in my junior year, I took a probability and statistics class.
I remember sitting there in the classroom thinking, wow, this is a really interesting problem, and he's using statistics and probability theory to try to solve it.
Statistics is amazing because it has many diverse applications, from search results on Google or Bing to recommendations on what you should be shopping for on Amazon.
If you're watching a YouTube video and at the end you get recommendations for other videos, statistics were used to give you those recommendations.
So you can continue with your own. So it basically says that there are, the application range and application, area is huge. So if someone in today's time just study one subject, and that should be statistics. Okay. So here you see that I'm basically, my main interest is research, and here I'll be showing you that, you see, recently, last year we published, this research paper, right? And this research paper basically it's a prom 1 and prom 2. This is kind of gene, human gene. So this expression differentially modulates clinical prognosis of cancer. So what we did is, the gene, how these genes behaves, in our human body, how their behavior and how they express in our human body, and what is the relationship with that genes with, cancer. So that we, analyzed, and that things basically we did all the analysis is basically statistical analysis, that we say multiomics analysis. In this multiomics analysis, we took, methylation data, genetic expression data, clinical data. So, and then based on that, we try to formulate some correlation between them. So we argue that perhaps, this prom1 and prom2 gene has various kind of roles in patients with different sorts of different sorts of cancers. So you see, this is, sometimes we say bio applications of biostatistics on molecular biology. So this is also possible. So I hope that it is sufficient motivations that you got, that why we need statistics. Not only just commercial things and development, we also need for extensive academic and industrial research. Okay, this is a very recent things, you see, that here, this is also again statistics. You see, this is the, number of new coronavirus, cases worldwide and for all time. And you see that it started, last year, and that it gradually went upward directions, and very recently it going downward. So if you see last 30 days statistics, it's then now the trend is going downward, because perhaps the vaccinations, the rolling out of vaccinations is came into effect. So as the countries across the globe, they are, they have started the vaccinations, and so the trend of new coronavirus cases becoming downward. So this is again these descriptions or whatever interpretations you come up with, again with the help of statistics. So to cover, some sort of basic knowledge that, uh, of probability and statistics, we designed this course, 3 credit course. And this 3 credit course, we will have 3 hours, weekly lectures. So Monday 9 to 10:30 and Wednesday 9 to 10:30. And the lecture type will be Blackboard, or sometimes we will have the WebEx lectures, or combinations of that. And if we have the WebEx lectures, definitely I'll be giving you the link so you can join the meeting. So and definitely, because of online lectures, so this is, 1 hour and 30 minutes. This will be shortened to around 40 minutes, for each lecture. So every week we have 2 lectures divided into 2 parts, part 1 and part 2. And the lectures type is basically theory, tutorial, and demonstrations. And please, these attendance rules 5 or 10 minutes before the lecture starting time, 10 or 15 minutes after lecture starting time, it will be late, and it will be counted as an absent if you come up with after 15 minutes or 20 minutes something. For online lectures, the things that you, if whenever we upload the lectures in Blackboard, you just go and watch the lecture. And if you don't watch the lecture, the server will not be, recording your watching activities, and you will be absent automatically from the server. And the teachers doesn't have, much control over that. So please, whenever the lectures is posted on Blackboard, please, open, you watch the lectures and try to gain some knowledge. If you give the effort, then you can learn the statistics, that I can assure. But if you don't have, interest, and if you don't give time, if you really, don't work hard, I think it will be really very hard for you to understand statistics. But if you really go with me, if you give some time, if you have interest, I'm sure that you will be getting a lot of things from me and from my lectures, because I know these things very well. I know what I'm going to teach and what I'm going to deliver to you, and I can relate those things into your application perspective. Also, it will be helpful for your graduate study. So this, whatever dimensions you think of, please, every week you study 4 or 5 hours statistics. Okay. So I mean, the assessment, midterm exam will be 25%, final exam is 25%, and assignment is 40%. And assignments, because of online things, it will be various kinds. It might be homework, quiz, or it might be survey or review or analysis. I'm not sure that we'll have group project or not. Also, we might have reporting, problem solving, programming. And what I will be doing is, because you really need to understand that what are the current state of art topics in probability and statistics, what are the different kinds of uses. So time to time, we will cover some we'll cover some of the latest topics based on conferences and journals, those things. So, but whatever the scores will be assigned here, the total scores obtained from all of the assignments, that will be proportionally converted ultimately. Okay, so let's say if we have 200 in total scores, so uh, these 200 scores then will be converted proportionally to 40%, and attendance will be 10%. And if we have objective type or subjective type question in midterm or final exam, it might be multiple choice, true false, matching problem, completion, short answer, extended response, problem solving, those things. This is very usual things that you already are somehow familiar. But if the new guys are not aware of, so that's why I'm just saying very quickly. Definitely the lecture slide will be uploaded in the Blackboard, so please go and check, and sometimes it will be updated at a later date. So and whenever the updated, I'll be writing the updated, these lectures has been updated on that date. And for online lectures, the content will be uploaded in Blackboards, and for WebEx lectures will be recorded so that I can share the lecture contents at a later time. So if someone misses, you can also go and watch that lectures. And definitely I'll be coming up with various kinds of references, and for online lecture notes I'll be giving from time to time, I'll be giving. And Python will be a very integral part of this course. So maybe 3 or 4 entire lectures, or maybe additional lectures I'll be giving, just to practice with Python examples. Because without examples, without daily life, real life examples, without doing in Python, you basically don't grasp the statistic knowledge inside you. So please everybody, you starts just little bit learning of Python, even though I'll give you some in a very concise idea of Python, but it still is better that you yourselves by this time you start with. So our course, that you understand that there are mainly 2 parts. One is probability and another is statistics. In probability, we will have concepts of probability and the probability distribution. And in statistics, we will have inferential statistics, that we say hypothesis statistics and analysis of variance. And we'll do the implementations in Python programming. Okay. So if you go just a little bit deeper in probability, we'll be covering this topic: conditional probability and independence, discrete and continuous random variables, and probability distribution, the concept of expectations and variance, central limit theorem, and estimation. And you know what, that these topics somehow a little bit familiar to you from your high school knowledge. So the first part will be kind of review to you, but with a deeper understanding. Now the next part is basically will be completely new to you. Most of you, it will be completely new. And this is the hypothesis testings. We'll be focusing on single and two sample hypothesis. And for ANOVA, that is analysis of variance, we'll be focusing on single and multi-factor ANOVA. And also this times I'll be giving some more attention to linear regression, because linear regression is basically the basis of all the machine learning stuffs. So if you know even just linear regression, you can come up with various kinds of predictions and various kinds of data fitting, those things. And then we will have the knowledge on goodness of fit and odds ratio. Okay, so as usual, please contact me my preferred way. This is islam.smriazislam@gmail.com, and this is my email address also, but use Gmail address, that is better. And whenever you contact, please mention your name and ID. And if you wanted to meet me in person, that is AI Deyang AI Center, this 434 is the room number. But please it is recommended that you just arrange a appointment. Otherwise I might not be here, or I might have some problem. Okay, so when you do email, every time I say to you, but many of you don't follow. Please follow these things, because formality is very important. And this structure will not only be helpful for here, it will be helpful for throughout your life, that whenever you do emailing someone, this is the email address, right? There are 7 components usually. You provide a subject line, you write clearly your probability course, and maybe you are asking about lecture or assignment or grade or project or exam or meeting, you just mention that. And then you write, dear Professor Riazul Islam, my name is Riazul Islam, and this dear, I might not be dear to you, but I mean, this is some decorum, right? We just follow. Then you introduce yourself with your name and ID. Then you describe your issue in details, that what you are talking about, or what's the issue that you are trying to communicate for. And then you just give thank you. And it is better again to give your name and details, even though you gave here. So this is the usual way that how I prefer that you communicate with me. Please, I cannot do the problem solving, assignment solving for you. We'll be discussing in the class, but the problem solving is specific, assignment solving, this is basically your job, because when you do so, you basically learn those things. And also that understanding over the email is very, very difficult. Even it's difficult to communicate online, right? That even the online is great resources, but when you think about the real lectures, not just crash course, if you go on YouTube, there are lots of crash course. They just summarize many things within just 30 minutes, but that's really not the lecture. The lecture should be very steady, in step by step, gradually, slowly. So ultimately we will discuss all of the lessons related matter in the class. And if you have some issues and you want to discuss something when we'll have WebEx lectures, please ask me at the time. Perhaps we'll be discussing other issues also, that as we do in our normal classroom. So normally contact over the email is basically for missing information, that you don't know something, that when something is going to happen or something, that kind of things. So do not submit assignment or homework via email. And these assessments rubrics, this time I'll not upload the separate rubrics, but whenever I give an assignment, I will explain that how these assignments will be evaluated, or what scores will be given. So you just follow that. And the university rules regulation, that you definitely will follow. And please be honest in your approach. I mean, look, just for a very simple grade elevation and just grade increase, don't tell lie, don't do cheating. And I know that many of you basically are busy with your stressful time in COVID, and also your family issues, sometimes your university lives, some Korean lives. So but your main focus, basically what your main focus is study. So please don't give up the study, because this is that what you really want. One thing, what, for example, perhaps you wanna be dad, right? You wanna be father. Now what is the legal way, what is the valid way to be a father. You have to marry, and you have to have certain, you have to maintain certain, process, right? If you don't marry, if you don't have certain process, then you can't be a father. So so to be a father, you need to, marry, you need to follow some process, then you will be coming. So the same things that you need to, you know study if you like to learn something. This is the recommended book, The Probability and Statistics for Engineering and Sciences. And see, this is the writer, J.L. Devore. There are, some similar books, maybe for engineers and scientists, but that is not the book that I'll be following. I'll be following this one, Probability and Statistics for Engineering and the Sciences. Even though there's the similar book, I'm not sure that I have the book here or not. Yeah, I have in my desk. Okay, I'll be showing you later. This book was also good, Python for Probability, Statistics, and Machine Learning. Maybe for Python, I might follow something from here in this book, but this is our main textbooks, you can say. And for statistics part, I'll be also taking some parts from here, elementary statistics. So this is also good to follow. Okay, so before I end up these slides, let's have some more names on probability and statistics application. So statistics can be used in banking, it can be used in robotics and automation, it can be used in natural language processing, it can be used in multimedia service, it can be used in network security, that how various kinds of packets are being hacked, or what is the traffic load. So those kind of pattern and quality of service can be analyzed by using statistics. Also in data communications we use statistics. In psychological behavior and analysis we use statistics. As I told you, in research we use statistics, right? So you see the statistics is here, machine learning is here. So what is the very common things? Both machine learning and statistics, they work on data, right? So machine learning is nothing new. It is basically some more data specific, and some very kind of procedural things of based on statistical concept. Okay, algorithmic things. Okay, so I mean, there are lots of data sources that ultimately we rely on for your research or for your study. Maybe one might be interested in World Bank data, one might be interested in UN data, one might be interested in maybe these kinds of international database, US Census Bureau and Statistics Korea. And there are many kinds of data sources. Sometimes you might be working on, how to say, for example, heart disease prediction, then you need to go the medical database or something, right? So similarly, we will be using various kinds of data sources when you need, or if you need, you can use from any source, you can use the data. So this way I've just finished this one. So this introductions one, and now how about this one? This is, we already finished the course information. Now we are good to start with the real concepts, you know the basic concepts of probability. Okay, I'm not sure that, I mean, that how many of you basically remain in this course, because they're in a drop period. Maybe some new students will be coming, and maybe one or two students will be leaving. So it will be good to wait 1 week or 2 week before we start WebEx lecture. So perhaps next week or next week I'll be starting WebEx lecture in addition to this Blackboard lecture, or vice versa. Vice versa means alternate, that maybe sometimes we will upload the lectures in Blackboard, and sometimes we will just conduct the lectures in WebEx. Okay, so this week our main topic is probability concept. So so what is probability? I mean, these topics we will be trying to cover. In fact, what is probability, and what is the concept of sample space and event, and we will have a review on set theory, because this is from your middle school and high school, all about your set theory, and related to probability, and something we'll have some exams and properties, and we will see conditional probability and Bayes theorem. We will see the independence, event and independence probability, and might be doing some sort of problem solving. Okay, so these basic concepts of probability will be covered. So what is the probability? You see, probability, these terms is come up with in various kinds of our daily life stuff. For example, you see this is a dice, right? When we do rolling a dice, we think of statistics, a probability, that what is the probability that it will be 2, or what is the chance that when I roll next time it will be 3, it will be 5, it will be 6, or it will be single 1. So we borrow the concept, I mean we use the concept, or we relate the concepts of probability with dice rolling. Also, the notion of probability comes when we draw card from a card deck, right? We have a deck of card, and you just randomly, let's say, draw a card, and then what is that card will be? It will be 10, or jack, or queen, or k, or it might be 5, 6, or it is black, or it is white color card, or it is heart, or spade, or some other. So then again, we have the concepts of probability here. Think about this kind of coin. When we toss a coin, like in a game, football or cricket game, we see the coin tossing happening, right? So this coin tossing might be head might be coming, or it might be tail, right? These things, it might be head or it might be tail. But if your coin is very fair, that means no biased coin. Biased coins means, if you take a coin and twist it like this, then every time perhaps you toss the coin, maybe every time head is coming or tail is coming. But this is a very fair coin, and this is a biased coin or unfair coin, right? So in these sorts of things, or we try to come up with the concepts of probability. So what I'm saying is that that is it possible to determine the chance of a occurrence of an event? For example, event, that what is the event? Let's say I have a dice and I roll the dice, and what is the chance that the face will be 1, the value will be 1? So maybe, I mean, generally we can say that there are 6 faces, right? That there are 6 faces, which is 1, 2, 3, 4, 5, 6. So the probability of coming of each face is 1/6, right? So this is, or sometimes you might have that, okay, the chance might be 50-50. 50-50 means that it might be happen or it might not be happen. For example, that you toss a coin and the chance that it will be head or tail, so this is kind of 50-50, right? Or maybe that, let's say you have this 5 ball, and there are 1, 2, 3, 4, 5 ball, and what is the probability, what is the chance that it will be a blue ball, not this orange ball? So definitely there are 5 ball in total, and there are 4 green balls, so you can say 4/5, right? So you see that when we are saying that, you see there, this is the chance is more compared to this one, right? So what it means, that if our probability, if our chance is very certain, that means that things will be happen. And if our chance is impossible, that means that event will not happen. And in between, it might happen, it might not be happen. This is 50-50, right? So that's why the impossible event means there is no chance. Certain event means 100% chance, and 50-50 means this one, right? And if it is not 50-50 but towards like this, we say unlikely. And if it is not certain but the possibility is more, we say likely. So we can generally divide in this kind of pattern, that impossible, unlikely. That unlikely means it will not be happen, but there is little chance that it will happen. And certain means it will be happen 100% sure. And likely means it will be happen, but we are not quite sure, a little. So it is a likely event, and this is random 50-50 chance, right? So what is probability then? See, for examples, this head or tail, true or false. You have a multiple choice questions, so our answer is A, B, C, or D. So it might be A, or it might be B, it might be C. So chances, what is the chance? 25%, right? So that means 0.25, 25%, 25%. And this was chance is 50%. This is 50%. Tomorrow it will be rain or not? Maybe chance is 50%. What is the amount of snowfall? Maybe, I don't know, maybe it might be 2 centimeter, or it might be 3 centimeter, or it might be from 2 centimeter to 3 centimeter, like that. Okay, so ultimately that probability is basically that it's a chance that something will happen, right? So that how we generally perceive the probability. For example, let's say if you just observe an event, for example 100 times, and you see in that that maybe 20 times a very certain outcome is happen, 20 times. So in that case we say the probability is 20%. For examples, that let's say let's say you have a dice, that I told you have a rolling dice, and you just see that, let's say you roll the dice 100 times, right? And out of that 100 times, 20 times you got the value 1. So we can say the probability of 1 is basically 20 over 100. So this is some sort of observation. So it means what? It means that we basically believe something is true. Then what is the strength of our belief that something is true? So that is basically probability. Or this definition, this Wasserman definition, that probability basically is mathematical language for quantifying uncertainty. Okay, so probability is basically quantification of uncertainty. For examples, we don't know that if we have, let's say 3 red ball and 2 green ball, so total we have 5 ball. Now if we just randomly pick a ball, what is the probability that it will be red? What I'm saying is 3 red ball and 2 green ball, right? So total we have 5 ball. So see, now if I randomly pick up a ball, definitely that's an uncertainty, right? But that uncertainty we try to quantify mathematically. So what is the probability that it would be red ball? So we can say the probability is 3 over 5, right? So that means on an average, if you just pick up the ball, let's say 5 times, so 3 times it will be coming red ball. But it is not sure. Sometimes it might be 4, sometimes it may be 2. So very long term, on an average, we might have 3 over 5, right? So that's why we are saying that we have some uncertainty, but we are trying to quantify mathematically that uncertainty. So that is called probability. So we'll start our next part from here, from exemplify, and we'll finish those things. We'll try to as much that as we can do. Okay, so we'll start our next lectures from this slide exactly. Okay.